The real voyage of discovery consists not in seeking new landscapes, but in having new eyes. That's Marcel Proust. And it feels very relevant today because we're about to get some powerful new eyes on our planet. We're doing a deep dive into a technology that's, well, fundamentally changing how we see Earth. Synthetic Aperture Radar, or SAR. And this isn't just some niche tech topic. It's really vital current affairs. If you're keeping up with global events, maybe prepping for exams like the UPSC, where understanding tech is crucial for both prelims facts and mains analysis, or honestly, if you just want to be informed, this is for you. We're digging into a source today that really lays out how SAR is, well, revolutionizing Earth observation. So our mission to unpack what SAR is, why it's such a big deal right now, and where it's all heading. Ready to jump in?
Absolutely. So the first question, obviously, is what is SAR? At its core, it uses microwave pulses. It sends them down. They bounce off the Earth.
Okay, like regular radar.
Sort of. But here's the clever bit, the synthetic aperture part. The sensor, maybe on a satellite or a plane, it's moving. As it moves, it sends out pulses and listens for the echoes from different positions. Then, through some pretty smart processing, it combines all those signals received over that movement. It basically synthesizes the effect of having a massive antenna, much bigger than you could physically launch.
Ah, I see. So it's creating this huge virtual antenna through movement and math, essentially.
Exactly. It's a bit like taking lots of snapshots from slightly different spots and digitally stitching them into one super high-resolution image, but, with radar waves.
And the big advantage comes from using those microwaves.
Precisely. That's the real game changer. Unlike your standard optical cameras, which need daylight and clear skies, microwaves, well, they slice right through clouds, smoke, dust, and they work perfectly fine at night.
Okay, so it's an all-weather, day and night capability.
That's it. Consistent, reliable imaging anywhere, anytime, no waiting for the weather to break or the sun to come up.
That's huge, especially for anything time-sensitive. Disaster response, monitoring tricky spots.
You got it. And this capability, it's directly driving the market growth we're seeing. The source had some numbers that really tell the story.
Yeah, I saw those. Really jumped out. Okay, so USD 5.42 billion market size in 2024. Expected to hit 6.17 billion in 2025. Okay, steady growth. But then, wow, the forecast rockets up to nearly $20 billion, USD 19.80 billion by 2034. That's a massive acceleration.
It really is. We're talking a compound annual growth rate, a CAGR, of about 13.83%. That's not just steady growth. That's a seriously sharp upward curve. Something's really fueling this boom.
So what is it? What's behind that kind of surge, nearly quadrupling in a decade?
Well, the source points to a few key things. One major factor, and it's maybe an unfortunate one, is rising geopolitical tensions globally. Defense budgets are expanding, and SAR's ability for persistent, all-weather surveillance, that's highly valuable.
Makes sense for defense and intelligence, sure.
But it's definitely not just defense anymore. Climate change is another huge driver. Think about responding to floods, wildfires, landslides. SAR gives you that critical view when optical sensors are often blinded by smoke or clouds. And then there's the commercial side. It's really taking off in areas like agriculture, infrastructure monitoring. There's just this widespread growing demand for accurate geospatial intelligence across pretty much all sectors.
Okay, so security needs, environmental monitoring needs, and economic applications. Is it also getting, cheaper or easier to actually do SAR now?
Oh, absolutely. That's a critical piece of the puzzle. The source highlights the impact of things like microsatellites, smaller, cheaper satellites, and reusable launch vehicles. It's just dramatically lowered the cost of putting SAR sensors in space.
Right, so it's not just giant, super expensive single satellites anymore.
Exactly. Now companies and governments can think about deploying whole constellations of SAR satellites. Dozens, sometimes hundreds.
And constellations mean better coverage, faster updates?
Both. Much better global coverage, and crucially much faster revisit times. Instead of maybe seeing a spot once every few days, a constellation might give you multiple looks per day, or even near continuous monitoring for some areas. Add to that, the simple fact that climate change impacts are escalating, demanding monitoring tools that work no matter the weather, and, perhaps most importantly, huge leaps in AI and data analytics.
The AI factor.
Yeah, AI is absolutely key to making sense of all the data pouring down from these satellites. It's turning that raw, complex SAR data into usable, actionable insights much more quickly and easily.
Okay, so it's like a convergence. Cheaper access, more satellites, creating more data, and then AI making that data actually useful for more people.
Yeah.
That really paints a picture of why it's taking off. So where is it making the biggest difference? Let's talk applications. They seem incredibly varied. disaster management, for instance.
Oh, hugely important there. Imagine a major flood. Clouds are everywhere, right? SAR can cut through that, map the exact extent of the flooding, see which bridges are damaged, even detect tiny ground shifts before a landslide. It gives responders real-time info when optical cameras are useless.
That's life-saving stuff. And for climate science.
Equally vital. Tracking deforestation in cloudy rainforests. SAR can do that. Measuring how fast ice sheets are melting, even their thickness. SAR, monitoring soil moisture for drought warnings or tracking land degradation over huge areas. It's essential for understanding our planet.
And defense, we mentioned the surveillance aspect. Does it do more?
Yeah, it's not just about taking pictures. SAR is great at change detection, spotting tiny differences between images taken at different times. It can help identify hidden targets, track vehicle movements, provide really reliable intelligence day or night, good weather or bad.
What about those commercial uses? You mentioned farming.
Yep, precision agriculture. SAR can give insights into soil moisture levels across a field, assess crop health based on structure, help estimate yields. It lets farmers be much more precise with things like irrigation and fertilizer. And the infrastructure monitoring is fascinating. SAR can detect tiny millimeter-scale shifts or subsidence in structures like bridges, dams, roads, even buildings over time.
Millimeter scale. From space.
Exactly. By tracking these subtle movements, engineers can spot potential structural problems way before they become dangerous failures. It allows for proactive maintenance.
Wow. Preventing a bridge collapse by detecting tiny sags from orbit.
Yeah.
That's powerful.
It really is. And this variety of uses shapes how we look at the market. The source breaks it down by platform, frequency, and application. So platforms. Spaceborne satellites is the big one right now. Global coverage, persistent view. But you also have airborne SAR on planes or drones, UAVs. That's more for tactical needs, very high-resolution mapping of smaller areas or specific inspections.
Okay, space versus air. And frequencies. You mentioned microwaves, but are there different types?
Yes, different frequency bands behave differently. Think of them like different flavors of microwaves. X-band uses shorter wavelengths, gives you really high resolution, great for fine details, like identifying specific vehicles or monitoring small structures. C-band is a workhorse, a bit longer wavelength, good all around for land monitoring, mapping larger areas. And then L-band has the longest wavelengths. This lets it penetrate deeper into things like forest canopies or even dry soil. So it's excellent for mapping forest biomass, detecting subsidence, or geological studies.
Different tools for different jobs. Makes sense. And the application's market share.
Well, defense has historically been the biggest chunk, and it's still very significant. But the real growth is happening in those other areas: environmental monitoring, agriculture, infrastructure, disaster response. It's shifting from being very military-focused to much more diverse.
It's genuinely encouraging to see this tech branching out into so many beneficial areas. So who's leading the charge? Which regions and companies are driving this? The source points to North America being out front currently. Strong government and defense investment there, plus a lot of innovative private companies like Capella Space, Maxar.
Right, but watch the Asia-Pacific region. It's coming up fast. China, India, Japan, they're all investing heavily in their own SAR capabilities for civil, military, and commercial uses. Europe's also a major player. With ESA, the Copernicus program, they're big on innovation and, crucially, open data access.
And other regions.
Yeah, places like Latin America and Africa are increasingly adopting SAR, too. Mostly for critical needs like managing land resources, environmental protection, and building resilience to climate change impacts.
So it's becoming quite global,
Yeah.
and the companies involved.
It's a mix. You've got the established defense giants, Lockheed Martin, Northrop Grumman, Thales, then specialists in airborne systems like Airbus, General Atomics. But a lot of the buzz is around the newer new space companies building those small satellite constellations. ICYU, Capella Space, Umbra Lab are key names there. Plus, companies focused on the data and intelligence side, like Maxar, L3 Harris, and even smaller innovators pushing the tech itself, like metasensing or IMSAR, working on frequency flexibility or smaller payloads. It's a really dynamic landscape.
Which brings us back neatly to AI, doesn't it?
Yeah.
All these satellites, all this data, someone or something has to make sense of it.
Exactly. Raw SAR data isn't like a photo. It can be complex, speckled, hard for an untrained eye to interpret. Traditionally, you needed highly skilled analysts, and it took time. AI, especially machine learning, is changing that completely. It automates things like cleaning up the images, reducing noise. But more importantly, AI algorithms can now sift through massive data sets and automatically detect patterns, objects, or subtle changes much, much faster than humans ever could, sometimes finding things humans might miss entirely.
So AI is not just an accelerator. It's enabling new types of analysis.
Absolutely. Imagine trying to manually scan satellite images of an entire country looking for illegal logging or new construction. It's practically impossible. AI can do that continuously. It can track vehicle movements across vast deserts, monitor urban sprawl in near real time, detect subtle signs of environmental degradation over huge areas.
And what about predicting things?
That too. Predictive analytics is a big area. Combine SAR data on soil moisture and crop growth with weather data, and AI can help forecast crop yields more accurately. Or use SAR-detected ground deformation patterns to predict landslide risk or potential infrastructure weak points. Now, the source is clear. It's not all smooth sailing. There are challenges. Getting enough diverse, high-quality labeled data to train these AI models is a big one. Ensuring the AI is used ethically, especially given the surveillance potential, is another critical consideration we need to manage.
Really important points. So, with all that in mind, what does the future look like? Where is SAR heading next? Well, the trend seems to be towards even greater accessibility. Satellites keep getting smaller and cheaper to launch, and this idea of SAR service, the SaaS model, is really taking hold.
Yeah, that SaaS model is huge. It means you don't need to be a space agency or a giant corporation to use SAR data. Smaller businesses, researchers, NGOs, they can just subscribe to get the specific insights or analysis they need, often delivered right through the cloud.
And cloud computing itself, plus edge processing, doing analysis closer to the data source, that's speeding things up towards real-time interpretation.
Definitely. And another big future trend is convergence. SAR won't just exist on its own. We'll see it increasingly fused with data from other sensors like LiDAR for precise elevation models, optical for visual context, hyperspectral for identifying materials. Combining these gives you a much richer, multi-layered understanding.
Fusing SAR's all-weather view with the strengths of other sensors.
Yeah.
That sounds incredibly powerful, like the ultimate Earth observation toolkit.
It has that potential, and we're seeing new applications pop up all the time. Using SAR for detailed mapping in smart cities, providing reliable terrain data for self-driving cars or drones, improving environmental forecasts, even maybe monitoring space debris orbiting Earth. So really, the picture the source paints is of SAR evolving far beyond its military origins. It's becoming a truly foundational technology for how we observe the Earth and make decisions globally. It's set for a revolution, underpinning everything from security to food production to climate action.
Yeah, with AI making it smarter, lower cost making it ubiquitous, and new service models making it accessible, it feels like SAR is shifting from being a specialist tool to essential infrastructure for navigating the 21st century. And that, I think, nicely wraps up our deep dive into synthetic aperture radar. We've gone from the basic tech and its unique all-weather power through the booming market drivers, the huge range of applications, the global players, the crucial role of AI, and a glimpse into the future.
And for you listening, whether you're deep in UPSC prep needing to grasp these key technologies, or just someone keen to understand the tools shaping our world, hopefully this gave you a solid handle on SAR. It's more than just tech specs, it's about new capabilities. So as the SAR data gets easier to access, gets plugged into AI systems, and becomes part of everyday decision-making, here's something to really chew on. How will this constant, all-weather, increasingly detailed view of our planet change things? Not just how we track environmental shifts or human activity, but maybe more fundamentally how our societies adapt to change and manage resources in the coming years. It's a big question worth pondering.
A very profound question indeed. Those new eyes Proust talked about really do change everything. If you found this deep dive valuable, please hit that like button. Definitely subscribe for more analyses of key current affairs topics like this one. And please leave your comments or questions below. We genuinely want to hear what you think and what else you'd like us to explore. Thanks so much for joining us on this deep dive. We'll catch you on the next one.